Lights! Hi, I'm Brian. Welcome to Autogefühl. We're here today for a very special report from Wolfsburg in Germany to find out all about lights and the effect they're having on cars, not just now, but also cars into the future. Now, if you're anything like me, you probably don't think a great deal about the effects that lights have on your driving till you stay out a little bit too late with your friends talking. You drive back at 2 in the morning, you crest over the brow of that hill, only to be blinded by the latest LED technology. Well, hopefully soon that's going to be a thing of the past. We're here today to find out how and why. This seems like a pretty great place to start. This is a Mark I Golf, and as you can see, this had one of the very first iterations of headlamps available. Now, I'm not going to tell you exactly how old I am, but let's just say I'm not in the first flushes of youth. And that means when I learned to drive with these. These are halogen headlamps. And that means they more or less did exactly what you would expect. They turned off and on, they got a little bit brighter, a little bit dimmer. That was about the size of it. After these, we came onto xenon. Now, we have moved on a huge way from these lights now. And if you want to see just how much of an impact they can have on your driving, well, I think it's about time we went and found somebody a little bit smarter than I am to talk to. What do you think? We've been joined by Dr. Niels Fullman from Function and Development from Light and Vision. And if you think that was easy to say without saying David Bowie from Sound and Vision, I can assure you it was not. Now, we are in a brand new Touareg, and they standardly can come equipped with the IQ lighting system, but this is a prototype. This is the next generation. And Dr. Fullman is here to show us what can happen with lighting in the next generation. So this is not just a standard Touareg. We have a lot of optional extras fitted in this car. If Jonas just comes round, we can see just what some of those things are. Now, we're going to get a very good overview of exactly what's been fitted to this car and what kind of impact it has on it. But this technology is going to allow us to show you exactly how this lighting system works and exactly what it can deliver to you on the road. Let's take a closer look. Okay, now I have to tell you, at Autogefühl we spend more than a little bit of time looking at the center consoles of cars. But I think I can speak without fear of correction. I've never seen one that looks quite this way. Can you please tell me exactly what we're looking at?
Yes, we're in a prototype car, so we fitted some extra components in. So what's here underneath that plastic cover, which I can remove, are the switches we need for the extra electronics fitted in the back. So let me cover that we don't press that accidentally. And all these other switches are there to turn on and off the added functionalities while we are driving. And then here, these sub-D ports in the back, this is only for the development process where we can access data from the car to make use of that in the development process.
Now, I have to tell you, for our North American viewers, one of my favorite features that I've seen so far are these two USB inputs here. Now, as you'll be familiar, there are lots of German terms that go along with these things. And I have to ask, Hella, this is in German, this means in English?
So this is actually the name of the manufacturer who provided the headlamp.
Ah, I see. And Spectra?
This is the manufacturer of the PC in the back, and we made that we can easily distinguish whether we want to access data from the front or data from the back.
Okay, now that makes perfect sense. Obviously, what I'm reading when I look at that is this is the input if you want a Hella Spectra on your car. And I really like that they've included that as a feature. But that's just my sense of humor. So let's take a closer look and see what the lights are doing within this car. So we have a starting position to look at to show us one of the things that this lighting array can achieve.
Yes, and so one of the things I want to show you is that we can project images onto the wall, and what we want to bring across is the possibilities we already have with these 30,000 pixels, that you're actually capable of bringing fairly detailed images onto the wall.
And let's take one step back. 30,000 pixels. Exactly what does that mean?
So they are aligned in 300 columns and 100 rows, and you could switch on and off each one individually. And you cannot only switch it on and off, but you can also dim it in actually 8-bit resolution.
So for viewers, that's a lot like the way we would think of pixels within a monitor display.
Yes, exactly. So it's LCD technology, so it's very close to what you know from your desktop PC, for example, from your monitor there.
And that gives us a huge amount of flexibility in terms of what we choose to display and where we choose to display it.
Right.
So we have the logo, but in practical terms, in practical application, what is the benefit of being able to do that?
So, for example, what we will see later is with this high resolution, you can create either new functionalities which haven't been there, or you can make existing functionalities way better. For example, the glare-free high beam, and bring that to a level where it's way more comfortable to drive. So bring that, let's say, to the next stage, and also to be more precise. And that's actually important for us, because being more precise means that we can bring more light onto the road. And ultimately, that increases road safety. And that's one of the things we're really concerned with.
Well, it sounds very exciting in theory. Can we get to take a look and see how that works in practice?
Of course we can. We'll start driving whenever you want to.
Great, let's go.
So, but before we do that, I want to show you what you can also do on the wall. And there's another thing, we can also animate it. So again, this is just to illustrate the possibilities 30,000 pixels already offer you. Because I want to remind you, this is a prototype car, so we build it up to answer questions. So within the development process, a lot of questions arise, and we want to answer them step by step. And one was, what resolution do you need? Are we talking about 1,000, 5,000, or 1,000,000? And we think 30,000 is already pretty good.
Okay, so the idea being that obviously what we're not trying to do here is to produce a cinema style projection.
No,
what we are trying to do is to heighten functionality for the lighting array, and also to increase the safety aspects of delivering this to the system.
Yes, that's the aspect. Okay, shall we drive?
Let's do it. So as we already said, we have an awful lot of additional technology in this car, and earlier on we found out, because I'm really quite a big fan of data and information, and I'm more than a bit jealous by this display screen in the car, which gives us all the information that we could wish for. But I have been told that unfortunately this comes at the cost of an airbag. So should we experience any slightly traumatic experience while we're out driving this prototype, I will be wearing this screen and may regret my words considerably. In the meantime, it's booting up, and the point of this is clearly so that we can gather data about the car while we're driving, so we can get real-time information about exactly what's happening with our lighting system. So we're booting. Do we need to do anything complicated to the system? It auto boots straight into the program?
Yes, it does.
Great.
And here we...
Now, if you can have a look at this, Jonas, just where my finger is pointing, this shows us in real time exactly what those LED arrays, and am I using the right term there? Are you happy with me saying that?
Well...
No.
Not completely.
No, okay.
And since what we're doing is technologically wise, we have LEDs in the back, we illuminate an LCD, and then we image that LCD onto the road. So the LEDs stay on for the whole time, and we are changing the LCD. So we are changing the pixels there.
Okay.
So that's the more correct way to describe it.
So the LCD display is active where the micro lenses are static, and that's a very important distinction.
Yeah.
It's a very important distinction, because we discussed earlier when we were having a lighting workshop about the difference between systems that work by detracting from power that's already being output, and systems that work by changing the power that's being output into different areas. And the reason that's so important is that we look towards the future electrification of vehicle fleets. We need always to be concerning ourselves with reducing the amount of power output and making systems as efficient as possible. Now,
so what I want to show you is that we can, when I swivel here a bit, and for example, you look at that grass wall there, the light distribution also swivels, and you could see that there on the screen that it's done electronically. And that's something new, because in the past we needed mechanical components for that. And since the angular resolution of 1 pixel is 0.1 of a degree, we no longer need mechanical components. We can do that all electronically.
wow.
So there's just one mechanical component remaining in that headlamp, and that's the load adjustment system. Because we not only need to adjust our low beam and high beam, but also the near field. So that's why we still have that mechanical component in there. So that's the next step to work on, to also get rid of that.
So in principle, that makes the system a lot more efficient, a lot more energy efficient, and a lot more durable. Would that be right?
No, it makes it a lot more flexible, because mechanical components, for example, also they are heavier, so you have more movement time. Electronics is inherently faster, and also in theory, mechanical components can break because of wear. And you don't have that anymore when you only have electronics. And also, because you were talking about energy efficiency, you make your whole car a tiny bit lighter. So in theory, you use a little less energy.
Now, talking about that energy efficiency, obviously as we do move into the electric era, we're going to be looking at conserving as much of that as we can. Clearly, we all grew up in a world in which the alternator provided everything we could ever want. So none of us really thought a great deal about burning through as much of that free energy as we were driving around as we wanted. But if you're going to be driving an electric vehicle, every single watt that you use has to come from somewhere and isn't being automatically regenerated. So is this system going to be more efficient than what has gone before?
In terms of when you compare that to, it very much depends on what system you're looking at. So if you compare that with a headlamp from 30 years back with no functionality, the answer is no. If you compare that with a current system with equal functionality, then they're on a fairly identical level, but energy efficiency is the next step in our development process, because what we try to do in our development process is to break it up into parts which are independent of each other. So here we focused on the functional development, because when we know the requirements from the functional development very well, then it's easier in the next step to focus on that energy efficiency and come up with better concept. If you try to do that all at the same time, it gets so complicated that you might not come up with the best answers.
So would it be fair to say that at the moment what we're concentrating on is improving the quality of the outcome without increasing the load of power and resource usage, and that we will bring those efficiencies to bear once we have identified what is the optimal system for lighting that we can deliver, period?
Yes.
And then we look to see how can we make that the most efficient that it can possibly be.
Yes.
That's actually really exciting, because it doesn't take a huge amount of driving around country roads at night in order to see quite what a big impact that has. Now, my car that I drove to the airport this morning, which was 4 o'clock this morning, was pitch black. And it does absolutely fine around town, but I have to tell you, once you get into those country roads, you really start to notice the lack of ability that those headlights have to adapt between an environment where there is natural ambient lighting and one where there is none, and especially when you have sudden weather changes, when you have mist coming down or sudden fog, the lights just have nothing else to give you. It really is very much a binary state between high and low, and that's it. Modern headlights have so much more flexibility built into them. What this system can deliver is a huge array of additional features on top of that.
And let me show one here. So, for example, when you're driving with a rental car and it's unfamiliar for you and you have roadwork conditions, you might feel unsafe in those situations. So what we can do is we project lines onto the road indicating the width of the car. So what it does is it not only displays the width, but it also bends according to the steering angle I apply. So when you do a lane change, it also helps you in that situation. So what I did in the meantime is I activated the automated high beam functionality, and when you have a look at the screen you can see the masks being applied to the high beam in order not to glare the traffic in front.
Wow.
And I now try to swivel a bit such that you can see how smoothly that mask is moved across. So this is one of the benefits this high resolution system has, that you can move it very, very smoothly and accurately. That was what I was pointing out earlier. So let me switch on the optical lane assist again. So what you see is that we can superimpose functionalities. So this already shows you the added degrees of freedom we have to create new functionalities. And so this was just one idea. So we have just started looking into that. So in theory, it's just limited by your imagination, your calculation power, and the pixels you have on your display. So the other thing we can do with that optical lane assist, since we create that image in real time, we are calculating it right now with roughly 30 images per second. We can change it according to your specifications. And let's imagine, given the time, you're a bit tired, so you want to have some extra safety margin. Well, we can just switch that on and widen in your car width electronically to give you that extra space. And you can also make use of that, for example, when you're towing a trailer. And you don't do that on a daily basis, so that can also help you in those situations. And what you see now, there's lots of oncoming traffic, and we can project a bright line on the right-hand side of the road such that the driver focuses on that side of the road, and therefore you not look directly into the headlamps of the oncoming cars, and therefore you can also not be blinded by the oncoming cars. So that's also another functionality which greatly helps to increase safety on the roads.
It's really quite something to be able to watch this very real-time display of our lights so we can see exactly what it is they're doing while they're doing it. One of the things that we were told before we came out on this drive is it's quite difficult to really get the full sense of some of these features because obviously we have all of the lights coming towards us, so we can't see the benefit that these cars are actually experiencing. But here with this display we can see exactly what these lights are doing and how that impacts on the coming traffic. It really is quite something to look at. So we've driven through a little bit of highway driving and had a look at that, and we've got a little bit of traffic so we can see how that relates to what we're doing right now. Come on, we've got lots of buttons here. What else can you show us?
So this is it for the moment, because in the development phase we focused on functionalities which are already within the legal limits of the ECE regulation. Because our perspective is that it only makes sense to develop functionalities which you can actually bring onto the road and offer that to the customer.
The EC regulations.
Yeah, that is for Europe.
This is why we have the Hella Spectra function for the North American market.
Yeah, well,
I like it. It will be a thing. Trust me, it will be a thing eventually.
So the other thing we are looking at, but this is still ongoing research, is that for autonomous vehicles, you need to communicate with the outside world. So we are looking into how this system can help there. But this is such an early phase we are in at the moment that we are still brainstorming there. And it's not only we as a brand, but this is the whole industry. So there's legal experts involved, so there's psychologists involved, there is road experts involved, the authorities are involved. So that's still an early phase. And with that prototype car, we will also be able to answer questions arising in that process. But since we're in that early phase, we don't have anything I can show you yet.
So you spend quite a lot of time with magical thinking, with lighting design, about what you would love to see. If I said that we could snap our fingers and make anything possible, what is something that you would love to see achieved with lighting in the future?
Well, one of the most difficult driving conditions you can have is actually heavy rain or snow. And it would be brilliant if we would come up with an idea how to help the driver in that situations to have very good lighting on the roads without being glared by your own traffic light. And that is a huge, huge challenge.
Now, does that work? That's okay, forgive me if I'm not using the right terminology. That's about refraction, right? The light coming...
Well, it's back reflection, basically. Because
okay.
when you have either fog or snow, it's basically that you have water in the air, and when you hit water, let's say a sphere with light, then it is back reflected, and then you're glared by that one.
So this can be observed by the camera.
Yes.
That can then affect the modulation. Again, you know, you guys are probably laughing at me. Okay, this guy obviously knows what he's talking about. I'm winging it. I'm doing the best job I can. So the camera here is looking to see what the impact of the light on our environment is. It observes that we are having a lot of reflection from this water in the environment, and it then controls the modulation, the frequency, I want to say. Are you going to laugh at me? You are going to laugh at me, aren't you? Oh, come on, guys.
So what you would... Well, in theory, what you needed to do, instead of masking out the car, you would have to mask out the individual water droplets. But obviously you can't do that, because then you basically switch off your light. So the question for us as software developers and lighting engineers is, can we find another way in order not to be glared and still have the maximum light on the road? Okay,
can I ask you, you're a very clever person, and I want to ask you a very stupid question. Is that okay?
Yeah, that's fine with me.
So I was listening to a podcast earlier today, which I was really quite excited about, and it was a couple of sound engineers, and they were talking about how they really wanted to create an effect with an audio stream where it was loud, and they weren't allowed to do that by the broadcaster. So they were talking about taking specific bands and changing the density within those bands in order to affect the oral trickery that it was loud when it actually wasn't. Now, here's my stupid question. Can you change the density of light? I did say it was a stupid question. Can we change the density at different frequencies of wavelength in order to change the way the light interacts with things that it's hitting?
Yes, you can do that.
Yes! 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 In your face!
But you can...
Oh no, there's a but.
You can only do that in the laboratory.
Oh. Okay.
At the moment you can only do that in the laboratory, and you need some special lasers for that, but I have seen that being done.
Ha! So it's not the stupidest question you've ever heard then?
No, you can do that, and there are applications for that, but as far as I know, they are all very scientific, basic research questions.
Right.
And
okay.
It's not something you can fit into a car. Trust me, it needs way more space than that.
It's a little bit much. Now, I tell you what I would love to do if you have time for us. We talked earlier on about how this is really quite a challenge from a processing perspective. One of the things I really enjoyed about today, we got to see how much some of the lighting technology involved has shrunk over a period of time. we have quite an impressive piece of kit in the back of this car. Would you have the opportunity to just maybe show us that briefly?
Yeah, we can do that.
So we
Sure.
can see exactly how all of this happens. One of the most important features of research and development is not only about making it work in the first place, but it's accumulating the data that any new system generates in order to properly understand it. So it isn't simply a question of putting the technology in, you also have to be able to understand what's happening with it. Which leads me to this. So, can you please tell me what it is we're looking at?
Yes, so this is the computer where we have seen the screen in the front. This up here is the extra power supply. Down here is data we get from the car up to here, and this is the data we send to the headlights, and also here on the bottom. So we gather data, do something with it and send it back, and since we're doing image calculations in real time, that means 30 images per second, we need a real-time environment, and this is done in this box up here. So you get the data from here, process it in the PC, send it to the headlight, and that's it.
So a lot of this has to do with the developmental stage, but in order to make this system a reality, in order to make this system something that would standardly fit to cars, what needs to stay from this, and what size does it realistically need to get to?
So this is in the car anyways, but we put it here for development purposes. So that can be just very, very tiny. So basically we need to shrink this and that to roughly that size, and that's totally feasible.
Totally feasible. You heard it here, folks. So how long is it going to take you to do this?
Well, a couple of years, because we need to do hardware testing and software testing. So I guess it will be at least three years, and we're gathering experience. So it might be more, but just a little. It's not a decade.
Well, I don't know about you, but I'm really looking forward to that. But you know, come on, by your own admission, you need to figure out this snow and mist thing. Come on. I don't care if you have to imaginarily disappear every individual drop. You know, that's why you're clever people. Make it work. We can't wait to buy that technology. Thank you so much for spending the time with us. It really was a great pleasure to see the system.
Thank you.
And we can't wait to be able to try it out for ourselves. 1972, things looked a little bit different back then. Now we are in a second generation Volkswagen Beetle. And I'm happy to tell you that the lighting has come on quite a long way since the technology that was applied to this car, but it really isn't that bad at all. And I have to say, if you can pick it up on the mic, listen to that engine. Now, I have a little bit of experience where Beetles are concerned, and I have to tell you, I've never had one that sounded quite this nice. So our driver tonight is
Nico.
Nico, a pleasure to meet you. Tell me, how much time have you spent driving this car?
2 days.
2 days. And have you driven one of the newer cars with the newer lights?
Sure.
Okay, and tell me, have you taken this out around town?
I haven't, but I drove it here in the Autostadt, so...
I think that's a slightly more friendly environment to drive it in, but I love the sound of that engine. Let's take it for a little spin and see what it can do. So tell me, Nico, have you ever worked on one of these engines?
No, I don't.
Well, if you've never had the pleasure, I can tell you that whilst this car is responsible for one of the most dramatic upshifts in productions of automotive history in the entire world, it is also one of the biggest pigs to work on. If you actually have to get access to that engine, it is incredibly tightly compacted within the back. And as for the electrics, well, let's just say that I hope you don't have any mice that live around about where you do, because they really have a bit of a flavour for the wiring loom of this car. Now, as you can see, I think this makes a very good impression of just some of the ways in which lighting have moved on so far. We have a decent spread across this road, but there's absolutely no attempt been made at focus or any real attempt put towards understanding the relationship between the driver and the other drivers out in their cars. So if you're driving in a perfect environment like this, and in fairness, I think the predominant use of this car when it was launched was in fairly well occupied environments at the time, you don't really need those headlights. But The moment that you get somewhere dark and just a little bit rainy, you really do start to see why the new lights have a little bit of an edge. Well, we've learned more than a little bit about lights tonight, and I have to be honest, I am pretty much blown away by not only what we've seen tonight, but also what's achievable in the future. But I have to tell you, I know the lights are less than ideal. I know the cars are troublesome. I know that there are lots of manufacturer problems and that ultimately they're going to descend into a small pile of dust sitting on your front driveway. But come on, my heart still belongs firmly with the classics. I love the modern world. I love everything that it delivers and everything that the future promises. But come on, what makes your heart beat louder? I know what does it for me. Well, that about wraps it up from us here tonight in Wolfsburg. So if you have any comments or questions, please pop them below. Please subscribe, and we hope we'll see you all again soon.